Welcome to day 7, Advanced Functions in Python. In the context of data engineering, Python plays a very critical role, and therefore we are going to learn today three functions which are important in terms of data manipulations. These three functions are being widely used in the context of data engineering. The three functions are: first is Lambda. Lambda function is used to write small anonymous functions. There is a certain syntax to it. We'll look into it. Then map. Map simply applies a function to each and every element. Third is filter. Filter is used to conditionally filter out the records or elements. These are the hidden workhorses in many pandas, PySpark, and ETL transformations. Let us start with what is Lambda function. A lambda function is one library. Lambda function is one line anonymous function, as I mentioned, right? It's a one line anonymous function. It is used when you don't want to formally define a full function with definition. There are many situations in which we don't want to segregate a logic separately into a section and want that expression or that operation to be seen right away at that point in time. This is a place where lambda function comes of use. Defining lambda function is quite a simple. There is a proper syntax to it. You simply write lambda, then you define a keyword which act as a iterator, and then you write down the expression that you want. Expression is nothing but the operation that you want that variable to perform. The simplest form to understand lambda function is calculating the square. So for creating a function to calculate the square, let's start defining lambda. So we wrote the keyword lambda, then we put an argument x, and then an expression. Whatever is the value of x, just multiply it with the same value and return the answer. Now this entire expression is present or can be defined into a variable, and then that variable can be used to call. So let's print this out. Let's change this value and you would be able to see the difference. Let the cluster starts and then you will be able to see the answer. Okay, 6, if we pass 6 we get the square value as 6 square. Moving to next function called map. Map is simply instructing Python to iterate a function over the entire over the over each and every element. So that's how map is defined. So map has a certain way of defining it. Map, you just pass the function first, and then in the second argument you passed an iterable. Iterable can be dictionary, list, array, anything. So let's take an example. With example you will understand it better. This is a sales array. It contains different values of sales. Now, um, let's define a function called discount, and discount you need to apply to the entire sales values. You just don't need to apply to a single value, but you need to apply to an entire value. So the idea that map function would come handy. So let's define the discount first. Discount is nothing but a lambda function where you just write an argument and an expression that okay, whatever value is there, just multiplied by zero point 0.9, so we are giving a 10% discount. Now this function you just need to pass it to a map. Map would take two arguments. First one is a function which is the defined lambda function, and second one it would take it as an iterable. The iterable is sales, which is an array. Now map will instruct the discount function to be applied to all the sales elements, and it will simply return an array back. What we do is we convert it to a list and print that out. Let's see. Let's say I wanted to give a discount of 20%. which is like the value will be 80% of it. So simply you can see the values are changing. So this function is then applied to each and every element and the values are printed. This is the power of map function. Then comes the filter function. Filter function is then used to filter few things like select items based on a condition. Only conditional items will be selected. Not all the values will be selected. These are very common data engineering scenarios, and that's why we are covering this as a part of an example. Let's say again filter is having a certain syntax. The first is the function or lambda function that we define, and second is the iterable, which is again an array or any kind of a collectible or iterable. So simply we define a discounted price function. We simply define here in this case I don't think, yeah, we have not defined a function, so we are simply putting the function here. As I mentioned, right, sometime there is a need that we need to see the logic right away right there. So lambda x argument expression 80% of it, and then we pass an iterable to it, correct? Then we apply the filter. So what filter will do is it will iterate the lambda function all over the it will iterate the lambda function all over the sales array, and it will print the values. So a discounted price array is then printed. Now what we are simply doing is we are combining the map and filter together. What we do in map and filter is actually this implementation is not the right example of filter, because filter needs to have a condition as well. So um, what we simply do is, let's take this example. Okay, here is a good example. So combining map and filter. um, so let's say we have an array of sales where sales numbers are present. In the first step, what we do is we try to calculate, we keep the high sales, like only values greater than 10,000 are kept and rest of them are filtered. So what we want is we want a function where we simply take a value which is greater than 10,000. This is our lambda function, and then it is an iterable is passed which is sales. What filter will do is filter will apply this condition to all the elements of sales, and it will discard all the values which are not satisfying this condition. This way we can see that a 10% we can see that that only high value sales are then kept. After that what we do is we apply a map function and apply a 10% discount to the values. Again a lambda function is applied to a filtered array. So first we discarded 8,000 values, 8,000 as an element we discarded it as a part of the filter, and then as a part of map we applied a uh, we applied the 10% discount, and then we printed the discounted array only. Let's take that. So yeah, again sorry, we can see that 8,000 and 6,000 two values are there which are not greater than 10,000, and therefore they are being discarded. Only 12,000 and 15,000 are kept, and on that also once the discount is applied, this is the final answer. Reduce for aggregation. If you need to aggregate all elements into single result, we use reduce for function tools. Reduce is another important element where we may want to aggregate on the values. So we use something called reduce. Reduce again the same. We use lambda function, and we need an iterable. In reduce what we simply do is we can do a plus, whatever we want to do we can do it here, not a problem. So but what reduce will do is reduce will take first element Reduce will use like a two pointers, and then it will start adding the things up. XY, what operation you want to do? You wanted to do an addition, so that way you can add all the elements and get the answer. So let's say if you just multiply, that is also possible. I can simply multiply, all the elements are then multiplied and total sales are produced. Let's go over to something called data engineering pipeline example. Since we are learning all these things in the context of data engineering, let's try to understand it in terms of data engineering pipeline example, where we are cleaning and validating the data. Let's assume we have an customer array where the customer names are present. Now you can see that customer names are having some problems, where you can see that there are extra spaces at start and extra spaces at end. So what we simply want to do is to clean up the array. Array is an iterable, so therefore what we can use is a lambda and map function. We define the lambda function where an argument and expression is defined, where expression is simply stripping the extra spaces from start and end. The leading and trailing spaces are trimmed. So each and every element is so that this operation is applied to each and every element, a map is being used on customers. Using map, make sure that strip is applied to all the elements, and whatever we get as an output is uh, simply an array where there are no leading and trailing spaces. Moving to next step is filtering. Again the same thing. What we are doing is we are trying to filter out the names which are coming as empty. So similarly, we can put a lambda function where an expression is like x not equal to empty. So those items where value is empty will not be made as a part and will be discarded. So we pass the cleaned array. So you simply pass the clean array and get it filtered out based on the condition that it is not empty, and only valid customers are then put into the final list. So valid customers are without any leading or trailing spaces, because we applied strip with map, and then we applied filter where we filtered out all the empty customers and only received the valid customers. So like this we can apply the cleaning functions. Moving to the next example where we clean, and again another example where we simply clean and validate the data is with numbers. We have a sales number or sales array. uh, what we are simply doing is we are using lambda function to define using lambda function to define what is a high and low value of sales. So let's say lambda x, then we are defining a condition that if x is greater than 1000, then simply say that sales is high, else low. And then so this is the lambda function, this is an argument, and then this is an expression. This is an expression where we say that high if x is greater than 1000, else you define it as low, and then you pass a iterable to it. So what you simply get is that 8000, which is, so it iterates over each and every element. So 8000 which is greater than 10000, um, it is high. 8000 which is less than 10000 is low, whereas 15000 and 12000 which are greater than 10000 will be marked as high sales. So these are few examples. So on the similar lines, I have done uh, an extract transform load where we are trying to use and filter and map as well. I think we have used only filter here. Only filter is being used here. Let me check if I have used map somewhere. No. So filter is being used, where you can see that in transform you can use the filter. I have again given one example where in cleaning and validation we have used filter and map. So this is the beauty of Python. Some of the advanced functions in Python in the context of data engineering, because there are numerous functions of Python. I am completely structuring this course and information specifically for data engineers. Okay. Functional programming, we have seen, like in last video we have seen functions. This we are again seeing some advanced function. So functional programming element is being introduced for data engineering pipeline, so that complex pipelines can be structured in a right way and they become maintainable. Maintainability is an important aspect. Over the years, what people have thought is just go and write the sequels. If you start creating the entire structures that way, then your data pipelines become more and more complex and less maintainable. Putting it in a functional programming way helps you to go a long way in building a maintainable system. Functional programming helps data engineers write shorter, cleaner, and faster transformation logic. When combined with a modular design, we are modularizing it with functions. It lays the foundation for a scalable ETL job that are easy to maintain and debug. So this is the idea behind putting this or stressing upon the importance to learn function and do functional programming for data engineering. Thank you guys for listening to this. In the next video, what we are going to learn is something related to strings in Python. String being very important thing, why they are important for data engineers, we'll understand in the next video. Thank you. Thanks guys.